Welcome to Mastering Mathematics. Here's our instructor, Dr. Karen Wester.
Hello Antigua, Barbuda and the rest of the world. Welcome again to another in the series Mastering Mathematics. It's a program sponsored by the Ministry of Education using its EBE unit, its Center for Mathematics Education and ABS Television. Right, we're in a lot of hurry today because what? Yes, one more week and then the second term is finished. And what we have? Exams coming up when? The 20th of May. Can you imagine how quickly a year has gone? So what do we have to tell our students all the time? We've got to work the days. We've got to work the hours when we have them. Today, we hope to put to rest the whole topic in geometry with circles, because we have given you already everything you need to know right now, and I need you to get your little books, get your information out, that you don't see me going around with a big text or anything, because the salient points that you need to know will be written by you, because you're saying, do I know about angles on a straight line? Do I know about vertically opposite angles? When three lines form a close figure for a triangle, what do I know about that? What are all the theorems associated with triangles? Do I know them? Do I know an isosceles triangle? Do I know its properties? Do I know about the equilateral triangle? And you start and you go around, you make your own notes. And again, you look and you say, what are congruent triangles? What are similar triangles? You make certain you know the informations, all right? And you know we have a theorem that says the exterior angle of the triangle is equal to the sum of the interior opposite angles. And you go and you look at your obtuse angle triangles. You look and say, suppose I wanted to find the side. I have three things I can use. What can I use? Pythagoras' theorem, if it's a right angle triangle. If not, if it's an obtuse angle triangle, then I can use the sine rule, or I can use cosine rule. Do I know them? Do I know how to use them? These are the things that should now occupy your mind. You should not be going into an examination and say, what again? Because you have done your homework. Then you go and you say, oh, after the triangle we talk about many-sided figure. What is the family name? And we say it's the polygons, okay? Do I know what the cosine figure is called? Do I know if they said what is a pentagon, a hexagon, a heptagon, octagon, nonagon, decagon? Do I know all these? And what about if they ask me to find the sum of the interior angle of any of these many-sided figures? Do I know that I can say the formula can be looked as 2n minus 4 right angles? Or can I say it as 180 times n minus 2? What about the exterior sum of the angles of any polygon? Do we know that whether the polygon has 100 sides or 3 sides, that the sum of the exterior angles is 360 degrees? It doesn't matter the size, okay? And then, do we know these words? Supplementary. What does that mean? Do we know the word that if you say the sum of the angles, that it's supplementary, that we mean they add up to 180 degrees? Do we know if we talk about complementary angles, that we mean that the angles add up to 90 degrees? And do we know what is the smallest triangle? Okay. And then after that, we would have given you that you have at least 13 theorems that you're supposed to know in relation to the circle. It's nobody's fault if you don't sit. Take care, be methodical, make certain you know all these things, okay? That is what academicity is. You have got to be precise, okay? It's no half-flushy job of, study this and You have to concentrate, make certain you're focused. If you're going to study, it's not how many hours you put in, but the quality of the time spent in studying. It is crunch time now, and we have got to make certain we start to internalize those facts. And it is not the teacher's fault. It is not your mommy's fault. It is now your duty to sit diligently and make certain that at fifth form you can be an independent learner. I will continue to bring some of these things to you in terms of your theorems, because we talk about angles at the center of the circle being 2 times the angle at the circumference. We talk about angle in a semicircle that is equal to 90 degrees. We talk about the angle between the chord and the tangent, that they equal to the angle in the alternate segment. We talk about angles on straight lines. Yes, they're supplementary. We talk about what any 4-sided figure in the circle touching 4 points on the circle, that it is called a cyclic quadrilateral. And what do we know about the cyclic quadrilateral? We said that the opposite angles are equal. And we also showed you that the exterior angle is equal to the sum of the interior opposite angle. Aunties, uncles, taximen, if we have lost you, these are the things you too have had to learn. You saw us putting them into practice. You have to write down your little dotted notes here. Yes, and make certain, doesn't matter who you are, okay? Get your little notebook, write down the little information, make certain we have them. And of course, we should know all the properties associated with parallel straight lines. These are the things that we need for our, and of course after that you're going to get into constructions. We talk about that another time. But really, we're concentrating now on the theoretical aspect of our circles. And of course we know the different parts. We know the definition. If they ask us what is the arc of the circle, standing on same arc, we know what the arc means. We also know the difference between the word segment and sector when we're talking about the circle. Because what did we say, Barbudans? We said that a segment has 2 properties. It is made up of a chord and bounded by a part of an arc. The arc can be major or it can be minor. We said about the sector that we have 4 components, because we have 2 radii, a fraction of the circle made up of 360, and a part of the circumference. So we know the difference between those 2. Okay? Now, I am going to take you to, and CXC is not making any jokes. CXC is not giving you anything you should not know. These are the informations that you should have at your fingertip, okay, and should be studying. And so the questions are based on that. I will now show you how to apply the theorem that we have learned and the properties we have to the circle to any question that would have been coming from CXC. I have just given you all the information. You must say, oh Lord, my head is swim jack. All them things, yes, we gave them to you in pieces. You know what I mean? I'm going to read this question first. The diagram is on the board, and this is coming from the June 2011 examination. We're going to take our time, because once you see what you have to look for, you're going to be home and dry and say, hey, I used to think that that was so difficult, and it is so easy. All right? So listen to the question first, and then I'm going to give you a little chance to relax, so you can be teasing and thinking about it and say, let me get ahead of Miss Weston. Okay, but you must say Dr. Weston, you know. You remember that? Okay, good. So here we go now. Yes, not a medical doctor, no, not at all. Okay, so don't come and say you're going to have one injection. Okay, the injection you're going to get is a dose of knowledge, and it has to be mathematical facts. Okay, and then after this now, here's the question from CXC. Because I just think we have a lot of students who like to do the practical aspect of it more than what I like theoretical part in terms of like the question number 9. So we are preparing you for everything. And this is what the question said. In the diagram, and this is our diagram here on the board, okay? In the diagram, WX, so we see WX, Y and Z are points on the circumference of a circle, and the center of that circle is O. T, Y, and V is a tangent to the circle at Y. Angle X, so here we get X, W, and Z is equal to 64 degree. And Z, Y, V is equal to 23 degree. And they have asked us to calculate, giving reasons for our answers, the measure of angle X, Y, Z. So we have to find X, Y, Z. And you know the three letters, the angle has to be located at the letter in the middle. The other one we have to find is Y, X, Z. Okay? And after that, so show you Y, X, Z. Okay? So right here, we have to find that. Y, X, Z. Yes. And then after that, O, X, Z. O, X, Z. Okay? So let me read it to you once more, and you're going on your little break and you're just waiting, because you're waiting to come back to hammer Miss Weston, because you know all the information I just gave you and you have them written there and you have been studying. Okay, it says in the diagram not drawn to scale, W, X, Y, and Z are points on the circumference of a circle center O. T, Y, V is a tangent to the circle at Y. Angle XWZ is equal to 64 degree, and ZYV is equal to 23 degree. And we have to calculate XYZ, the angle XYZ, YXZ, and OXZ. Take a little break now, and we'll be right back to show you how you can tackle this question.
Here at Five Mountains Primary School, we take pride in being environmental patriots. We are planting trees. We are recycling. We are composting.
Be clean, be green, be vigilant is all the children ask. Environmental patriots committed to the task. A message from the Five Islands Primary School.
Madam Moderator, I will address the absolute impracticability from a financial point of view as Antigua and Barbuda being able to sustain a major disaster without outside help.
The collective national efforts have earned Antigua and Barbuda the reputation for being resilient.
Don't miss the 2015 edition of the Lime Inter-Secondary School Debate. Listen as students across Antigua and Barbuda debate many of the issues that affect us, be it education, sports, health, or the environment. We will dissect it for you. So join us Tuesdays 8 p.m. on ABS TV immediately after the evening news. We debate it, you understand it.
If you know the answer to a question is incorrect and you cannot find the mistake, start over on a clean piece of paper. Oftentimes when you try to correct a problem, you continually overlook the mistake. Starting over on a clean piece of paper will let you focus on the question, not on trying to find the error. Always read my problems completely before beginning any calculations. If you glance too quick at a problem, you may misunderstand what really needs to be done to solve the problem.
Join us for a new series of Mastering Mathematics, Mondays and Tuesdays, 6:30 p.m. here on ABS TV.
All right, so you had your break, and we're right back now to tackle our question. And you read it, the diagram not shown to scale, and you're looking and you're seeing. Now, what are we seeing right away? That is why we gave you these words: radius, tangent, are definitions, okay? The properties so that we know them. And right away, anytime you hear about center of a circle, you would know with the center of a circle we're going to have radii. Isn't that true? Jetta, can you identify the radii in this question here?
OX and OZ.
Okay, so we have right away OX and OZ right over here, okay? What do we know about them?
They are parallel, they're making a isosceles triangle.
Why are they making an isosceles triangle?
Because both radius meet a chord at X and Z, and they have the same angles at X and Z.
Why do they have the same angles at X and Z? It's an isosceles triangle. Where did the isosceles triangle property come from? We're dealing with the radii for the circles. What do we know about the radii for the circles? Right. That is the first thing you must always know. The radii of the same circle, they are all equal. And it is on that basis that Jetta can say that this OXZ is an isosceles triangle. Let's draw it out for you so that you can see. Okay? See the triangle here we're talking about? OX is a radius, and OZ is also a radius. And these two, they're equal. The triangle isn't completed, as Jetta says, because they're standing on this chord, the chord XZ. See it right here? Okay, going across like that. He has further informed you that these two angles would be equal because they are located on the line joining the equal sides of that triangle. So every time you hear about center, look for isosceles triangle. All right? What else would we be looking for when we hear about center, Jetta, and we have 64 degree up there staring us in the face?
Yes, half the angle at the top is twice the angle at the center.
Exactly. The angle at the circumference is equal to 2 times the angle at the center. So that is where our theorem comes in. So if this is 64, then this would be equal to 128. Okay? And if we know it's a triangle and we have 2 equal angles here, if this is 128, what do we know about the sum of the angle for any triangle? The 3 of them add up to 180 degrees. So how are we going to get the angles at X and Z?
Well, I would minus 180 from 128, and that would give me
and that would be 52.
52.
Yes.
Then I would divide 52 by 2.
Yes. Why would you divide 52 by 2?
Because it's going between 2 angles.
Exactly. So these 2 angles now, each would be 26, and that is 26 degree. Notice we have 3 things to find. We're not even looking at those. We're trying to fit in our angles first, and then afterward we would look to see if we can say anything else. What else can we do? Why would they have given us this number 23 degree here?
Because
no, we have
YV is 23 degrees.
Yeah, but why did they tell us that? What's important about that?
Because the interior is equal to the interior opposite angle, something like that.
Stop saying something like that and say it's that.
It's that.
Okay, but because you're not.
It's 23, and so that means that.
Now, what Jetta is hazing there, because, and he's right, but just not expressing it here. First of all, you're looking, he sees an angle outside here, and he knows it's going to be equal to something here, all right? So what are we looking at? We're looking at a chord again, and we have a tangent. So the angle between the chord and the tangent is equal to the angle in the alternate segment there. So every time you look and see if you have a chord and if you have a triangle drawn on its back, and right here we do. Can you see this chord ZY that he just spoke about right here, and the tangent is there, and this is the triangle it's making here on the back of this chord. Can you see that? Okay, and I'm just going to do the inside here so that you see that little thing here. But this same line that we were using as the baseline for that is also shared with this triangle here. So again, and what did I kind of say it? I said the angle under the house is equal to the angle in the roof. Isn't that true? It's just that a hurricane came and blew the roof a bit over, right? So it's on the side, it's tilting, right? But so this angle here is also 23 degrees. Okay, very good. What else can we put in? Now, I don't expect Jetta to be picking up everything. I want you also to remember that this 128 would have been part of a circle that would have had an angle of making a complete revolution, which would have given an angle of 360 degrees. So what can we do? We can subtract 128 from 360 to get this angle inside here. Isn't that true? Right. Because we're going to need it as the out angle for the in angle here, right, to get this angle down here. Okay? So what Miss Weston just said, I just said that this is an interior angle. The angle at the center is equal to the angle at the circumference. Now this 128 refers to this one. What refers to this one? Because this is at the circumference too. And it has to be this outer one for this inside one. So we have to find that. And we're going to find that by subtracting 360, subtracting 128 from 360. And again, we're going to get that that's 2, and 2 from 5, and 2 from 5 would give you a 3, and that would give me 2. So I have that this outer angle here is 232, and therefore this is the angle at the center for this angle at the circumference. And then what did you say again? The angle at the circumference is half the angle at the center. So we know right away that this angle here would be equal to 1, and it is 1, and it is 6 degrees. So 116 degrees. Okay. Now, 1, 2, 3, 4. Now, if we had to look here, we really had to, and we needed this angle here, we could have gotten it because this is a triangle, isn't that true? So we can add 23 and 116, and then take it from 180. So you're going to get 116 and 23 is a 9, is a 3, it's a 1. 180 minus 139, and it is 1, and it is 4. So that this angle here is equal to 41 degrees. Okay, so we can get that. And we would know right away too. They are now asking us, so we can say, okay, stop for a while and see if we can get what we want. And so we can look and see that we have to get X, Y, Z. Do we have it? X, Y, Z. What is the answer?
X, Y, Z.
And that's 116 degrees because this is the angle at circumference is equal to half the angle at the center. Half the angle at the center. Just doing shorthand here to show you. And then we had to find Y, X, Z. Y, X, Z. And you see, you have to know how where things are going. And you see that that is equal to 23 degrees, because we're saying right away the angle in alternate segments are equal. Okay? Alternate segments. Okay, between the chord and the tangent. So it's just repeated. So the reasoning comes from you're repeating what the theorem says. Which theorem did you use to get that information? Okay? And the other part here that they're asking you is OXZ. And here it is OXZ. XZ. So you see, you have to know how to read your angles. The angle is in the armpit. You may say, but this is not X. The whole big angle is X. But they're asking us, X is divided into 2 parts, and they're asking us for each part, okay? So that is why you have to know what each is. And here, this would be equal to 26 degrees, because it's the base angle of the isosceles triangle XOZ. And as long as you start putting on all these information here, the examiner would know, oh, this person knows what he or she is speaking about. All right? So it's not a paragraph they're asking for in terms of reasoning. They're asking you to state which theorem makes you able to say something like that. Easy, ain't it? Yes. So again, we're reminding you, we're consolidating the things, we're telling you, this is what you have to do. You sit, you learn your theorem, you know you're looking for certain things. Do I have a tangent? So what should be coming? Radius and tangent. There's a theorem with that. I have the center of the circle. So what should be coming? Center and circumference, right? I am seeing radii. So I have 2 equal radii. So I have an isosceles triangle. All right, so what should be coming? And that's what you're saying all the time. And then you say, there is a chord here. Do I have a triangle drawn on its back? Yes. So angle under the house and in the roof, that they're equal, okay? And you'll be saying between the chord and the tangent equal to the angle in the alternate segment. Friends, it's not too difficult. We're not asking you to do anything that's impossible. And let me tell you something, you know. True. Right, Checha? If these people make these senior, more mature people get more than them with their young turkey brains, oh my gosh, we're going to have so many ceremonies, okay? But not too many people will be there. All right. So parents, continue to encourage, and your well-wishers and supporters continue to encourage. And one day you come and tell me, Miss Watson, I want to sit this exam. I want to prove to my son and daughter that I can do it, because I know you can. All right? And even if I have to work with you all night and all day, I will make you prove to your children that you can do it. All right? So you're going to be a next success story. Right, so we have come to the end of this session, and no, I didn't forget my grade 6 student. Grade 6 students, I'm giving you a little break right now because you did all sort of booster tests and everything, and I hear your teachers are planning to murder you again during the Easter vacation. So Auntie Karen wants to send you on a break right now, okay? Relax a bit. And for formers, no break for you as yet, because I'm sending you on a week's Easter break, all right? So right now, for the next 2 weeks, we have to get in as much as we can, because I want to give you this information to show you you can be a part of all the fete that's going to take place over the Easter vacation, but you're getting up early to do your work. Nothing in Antigua starts before 1 o'clock, 2 o'clock or thing in the morning for these fete. Only if you're going to the Juve. But if you're going to the Juve, you're staying up all night to do the question, to do some work, and then you can go and have fun. You understand? Mix work and play. Nobody's saying, oh, I have to stay up. No, you can say, all right, I want to go to so-and-so, so getting up at 5 o'clock and put in an hour and put in some work until about 9 o'clock. Have your breakfast, and then you go about your business. Right? Yes, it can be done. Okay? And if you stress and say, oh, I can even go, when you start work now, say, hey, I can go until even 10 o'clock, 11 o'clock. And then you still have the balance of the day to do a lot of fetting. All right? So, be wise, be prepared, because this time now you want to get your passport to the world, and you're going to show yourself that this is just the beginning. And we're not going to take any chances. We're not leaving rooms for cracks. So, be diligent and put in all the work you can right now. I'm going to see you again tomorrow when I'll have another problem for you. And then after these 2 days, you're going to say, man, let me get the questions myself because I can do them. So see you tomorrow, and we'll do another question to make certain that you are well within your grasp to solve these mathematics questions. See you then.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.